Hi guys, just in case you haven't watched my previous set of videos, which I sincerely hope you have, just as an intro to this one, which I think is number 5, what we are making is these Dixon style or Italian style tool holders, and we've machined a bar of material with this profile on it, and we're now ready to cut the bar into pieces and then machine this slot here. So this video will show you how we did that. So hope you enjoy. What I'm doing here is deburring the edges because these two sides are going to be machined anyway. So we're just taking the burrs off so that it'll sit flat in the vise on the shaper. Right, so we're about 2/100ths out there at the moment, and we want to go that way. Okay, so what we're trying to do is get this surface and that surface, which are machined at right angles to the table, so that I can machine this surface here, which is cut in the bandsaw. And with a bit of judicious tapping and adjustment, we've got it pretty right. Right, so we're within a couple of hundredths of a millimetre there. our stroke a few millimeters. Quarter inch in that direction. That's good. Make sure that's tight. And we're on slow speed. You can actually afford to speed it up a bit. See, I've got a short stroke here. Just tighten the gip on the vertical slide. Right, I'm just going to measure the height of this and compare it with the commercial item. Let's see how much we've got to play with in height. Back shortly. Right, so the commercial unit is that size. Just zero that. Right, so I've got 21 thou to play with to clean up this other side. So I'll just deburr that side so that when we put it in the vise it's not sitting on a burr. Run a stone over it as well. Because that surface is now at right angles to the bottom surface, we don't need to dial it in. We do need to set it square. And we've got 21 thou to play with. here. Zero the slide, take 10 for a start. There's 5 and see what happens. The fact that it's actually cutting thicker here than it was on the other side is telling me that my bandsaw is not quite cutting square. Right, so that was 5, so we'll take another 5. Yeah, that's a nice surface, that. No sign of tearing or ridging. So we've got, I think we'll take another 5 and then finish up with a final 5/1000 cut. This is the final cut. This should bring us down to final dimension, and it's not a bad cut. Not perfect, but it's not too bad. Right, so we'll take this out, deburr it carefully on all the corners, and then we'll measure it up on the plate and see how it compares. Right, so this is the block that we've just machined, and I've deburred it. You can still see some of the swarf there. So we're within 1/100 of a millimetre from end to end, which I'm pretty happy about. 1/100 of a millimetre being 0.4 thou. It's actually better than 1/100. fact it's considerably better than 100th. And we'll have a look at this surface. Need to shift the angle of gauge so you can see it better. This is a horrible indicator stand. It's in what's it called? No, it's not. It's a Chinese one. Anyway. Yeah, about 200ths there from end to end. Right, now we need to have a look at how square the surface is to the base, and probably the easiest way to do that is with, I've got a cylinder square which I will break out and check that. You won't be able to see this, but yeah, maybe you can if I lower the camera. Okay, there's a little bit of debris on that surface there, which doesn't help, but the room I'm looking, that looks fairly good. Right, so I'm quite happy with that. Now, we've got 5 more to go. Morning guys, welcome to part 5, or is it part 6, not quite sure which. Our next task is to mill this slot in each of the work pieces. I could do that in the shaper with an around the corner type cutter. I did build one and I did try it, and it was trickier than I thought, and I came to the conclusion, I've got a milling machine, why not do it the easy way? One can be a purist and do it all in the shaper, but the object at the end of the exercise is to produce these tool holders. So I've got a keyway cutter mounted in the mill. I have had a dummy run off camera, and we've got the heights right, so we'll set a workpiece up in the mill here and get started. Right, the difficult part is to get the height right. If the height is not correct, then the height of the slot, if it's too low, then of course it won't engage on the tool post. If it's too high, then the tool post won't lock. I did a dummy run and we have got it right, so we'll now proceed with taking the first slot. Just make sure we are clear there. Yes, we are. Now the slot depth is 5.6 millimeters. I apologise for the metric units, but this mil is metric. And we've got a VSD on the mill at long last, thank goodness, and we are running at about 550 RPM. So we'll just touch off on the back there. And our depth is 5.6, and we can take the whole 5.6 in one cut. So there's 5.246. Just a word about the VSD settings. I noticed that a lot of people have a VSD on their mill or lathe, and when they started it winds up very, very slowly over 2 or 3 seconds. When you buy a VSD, the acceleration time and deceleration time are set pretty conservatively over a second or two. And there's no need to have it so slow, and also a lot of VSDs are set to coast to stop, so that when you stop the VSD it coasts to a halt, which is annoying, it doesn't look good, and it wastes time. So I've got the acceleration time here set quite quickly, so if I start the VSD it winds up to speed pretty quickly, and I've also got DC braking enabled, and the deceleration time set to about less than half a second. So when I stop the VSD it stops, and I don't have to sit and wait for it. The little clonk that you can hear is the magnetic braking coming in, and the way that works is when you stop the VSD injects DC into the AC motor, and that attempts to lock the rotor. So we get a nice quick start and a nice positive and quick stop. Okay, well, just clean away the swarf here, and we'll touch off on this side, opposite side, and cut in the other direction. Just touching off here. Okay, well we've got the tall post turned around simply for the camera shot. So there's the workpiece, and perfect. It fits and it locks up. Now the reason I know that it's good is because the cam position, this cam position here, I've got a bit of a way to go. If I put a commercial one in, you can see that the cam locks about 30 degrees further than the homemade one, and that's the full travel of the cam there. If you look at this part of the cam, on the commercial one, the cam moves through from fully open. It moves through about 110 degrees. On my homemade unit, the cam is movement is slightly less, which is good because it means that if necessary I could widen the slot. I don't have to because it's locked really well. I did make a dummy some months ago before I started all this exercise, and I actually cut that slot too far up, in other words too far towards my finger here, and it dropped in alright, but it wouldn't lock because the cam ran out of travel. So that's good. So we'll do the other 5 units. Okay, well it looks at the outset that we're a fair way down the track, but there's still a lot of work to do yet. The next job I do will be to mill this slot for the tool. Now I could do that with the shaper, but I found that my shaper, and I don't know whether I'm doing something wrong or the tool's wrong, but my shaper doesn't like plunging very much, so cutting that slot would be fairly hard work. I'd have to plunge a groove there, plunge a slot there, and then cut the material out between. Cutting the material out between is easy, but plunging that slot is a bit of a mission. It's quite slow on the shaper, so I will do it on my horizontal mill, my Harrison, which you may have seen in other videos. I haven't used the Harrison very much, and this will be a good job for it. So that's that task there, and then I will need to tap and drill and tap the holes for the fixing screws, and also make the attachment for the height adjustment. That'll be a turning job, and I've got 1, 2, 3, 4, 5, 6 to make. That won't be a big task. And now that I've got a VSD on my mill, drilling and tapping these holes won't be too much of a mission either, because on the mill I have a jog facility, so I can jog in one direction and jog in the other direction. I've got it set too fast at the moment for tapping, but so that'll make power tapping a lot easier than it used to be, because I didn't have reverse on this mill before. So thanks for watching, guys, and part 6 or part 7 coming up.